What is linear algebra? It's the study of solutions to linear equations. Why do we care about linear equations? Linear equations are everywhere in science, in math, in engineering, computer studies. You can do very simple things like F equals ma or V equals IR. These are all linear equations. I'm going to give some background knowledge here. So a linear equation is an algebra equation that has variables only to the first power. You can't have anything else. So no square roots, no squares, nothing like that. So very simple examples are, things like this. ax plus b equals 0. This x is our variable. This is another example. So you have probably seen things like this. Y equals 2x minus 1, the equation of a line. The variables in this case are a pair or a couple. It doesn't have to stop with two variables, right? You can have any number of variables you'd like. And so here the variables would be x and y and z. So the most general way of writing a linear equation for us is going to be something like this. a1, x1, a2, x2, down to an, xn equals sum b. a1 through to an, these are all going to be elements of the set of real numbers, so they're all constants. And the variables, in our case, they're going to form what we call an n-tuple. It's more than a couple, it's more than a triple, it's just grouping them all together. Our primary focus is going to be solving linear equations. So a solution to a linear equation is some value of the variables that makes the left-hand side equal the right-hand side of your equation. And it's going to turn out that some of our linear equations have more than one solution. So a really important concept that we're going to talk about is something called the solution set. So this is the set of all solutions to our equation. So this is an example of a single linear equation with one variable, x. A solution is when x takes on the value -5. There are no other solutions. So in this case, the solution set, we put solutions inside of these curly set brackets, just to tell everybody that this is the collection of all the answers to this problem. It's really important for us to start classifying equations by the number of solutions that they have. Linear equations fall under one of three categories. There's something called a conditional equation, and this is where the left-hand side is going to be equal to the right-hand side on the condition that the variable takes on certain values only. Now that example that we just saw right here, 7x plus 35 equals 0, the left and the right will only be equal to each other when x is -5. This isn't true for any other value of x. So this is what we call a conditional equation. There's another type of equation called an identity. This is where the left-hand side equals to the right-hand side for any value of our variable. You say, well, how does that work? Here's a very simple example of a linear equation. So x is our single variable. This equation can be written as a 0 equals 0. The left-hand side of this equation will always be the right-hand side of this equation for any value of x. Any one of these x could be solutions. X could be 0, x could be 1, x could be -6, x could be pi, x could be e. It doesn't matter. That means there are infinitely many solutions to this equation. We can't possibly list them all out. It's impossible for us to write every single real number. So instead, what we do is we create a different notation. We'll say that the solution is going to contain all values x. This vertical bar means such that x is a real number. Now there's a final type of equation that we are going to see a lot called a contradiction, where the left-hand side will never equal the right-hand side for any value of the variable. So 2x equals 2x plus 1. This could be reduced down to 0 equals 1. This is always false. The 0 equals 0 above was always true, whereas the 0 equals 1 is always false. there is no value of x that makes the left-hand side equal the right-hand side. And that means there are no solutions. And if there are no solutions, that means that the solution set has to contain nothing. The solution set is empty. So you could literally take a set, put nothing inside of those set brackets. It's an empty set. Or you could write this strange symbol. So this symbol denotes the same thing, the empty set. Don't put the weird symbol inside of the brackets, because then you no longer have a set that's empty. If an equation has answers, it's called consistent. It has at least one solution. And if it doesn't, it's called inconsistent. No solutions. So you should be able to see for yourself that a contradiction is an example of an equation that is inconsistent, whereas a conditional or an identity would be something that is consistent. Now, one other important concept that we're going to talk about is this idea of an equivalent equation. So these are two equations that look different, but have the same solution set. And whether you realize it or not, this is the kind of thing that you have been working with your whole math lives, especially in high school. So for example, the solution set to this equation is -5. You are taught that when you want to solve an equation like this, you always rewrite the way things look to make them look simpler, but still preserve the same answers. These two equations are totally different. They are not the same, but these two equations have the same solution set. All of these ideas are going to be put together for us when we get into the main topic for this course, which is systems of linear equations.